So yeah, two more things to talk about correlation, and we'll actually come back and revisit this in 3.4. But one is what can go wrong. So again, I can't emphasize this enough. It only tells us about the linear relationship. So if we don't do a scatter plot ahead of time, we might throw away a useful relationship just because it was nonlinear. It doesn't mean causation. We have that whole website of spurious correlation that, you know, cheese consumption per capita is strongly correlated with number of people who die by being tangled in their bed sheets. So we can't imply causation. The only way we have causation is if we're talking about a randomized experiment. And then a reason why we can't imply causation, there's always the possibility of lurking or confounding variables causing some sort of relationship that we can't really see because we haven't collected them. So the last piece is just how to calculate this with your calculator, the TI-83 or 84. Note you will never need to do this on a test. So this is just something that we're doing right now to prove a point. In fact, you would never even do this on a project or anything. You would use StatCrunch. So this is a little bit silly. So it's all there. I'm going to go ahead and do it. Do I even want to? Yeah, I will. It makes me sad, but I'll do it. Because half of me just wants to do it in StatCrunch instead. But it'll be easier with the little Wabbit guy. So I'm going to go ahead and do this. There's no reason to follow along. The takeaway is more what happens at the end of this one. So in this exercise, we have the data showing the magnitude of earthquakes and the number of deaths from those earthquakes. And so, of course, it makes sense that magnitude would influence deaths and not the other way around. So we got magnitude labeled X. And we're going to go into stat. I'm going to choose to edit this thing. Don't move. I see you trying to, bastards. Sorry. So you move something to the top of the screen. Oh my God, terrible, terrible things are happening. You move something to the top of the screen and Windows assumes that you wanted them put it in a certain area. Nope, don't do it. Whatever, this is as good as I can get. So you won't be able to see me typing in numbers, but we'll all survive. So I'm going to edit my lists. Again, to clear a list in the 83 or 84, you go up to highlight the list, press clear and enter. And I'm going to enter all the X values. I know you can't see the bottom of my calculator. You're like, how is she typing the point to? So dumb. 6.6, 6.9, and 7.4. And then on the other list, I'm going to make sure I type in the Y's so that they line up and correspond with the X's. So 60, 503, 115. Oop, that's not 115. 65, 62, and 1. Oh my God, I skipped something. This is terrible. Oh no, I entered 6.2 twice on the other side. You guys noticed this, I'm sure. And we're like yelling at me through the YouTube video. I can delete that. Okay, and just double check everything lines up. Good. All right, so now, again, don't feel the need to follow this, but if I was going to do this, I need to actually go into the catalog, which is second and 0, which I know you can't see. I need to go down to D and choose diagnostic on. So then once that's done, I can go into stat, calculate linear regression. And so if you don't have diagnostics on, you won't see the R squared and R here at the bottom. But based on this, we have an R of 0.7317. So I'll write that down. No! Sorry. The thing does not like, tablet mode does not let me have two things open. So R is equal to 0.7317. So by itself, if we were to interpret this, again, here's a place for you to pause, try out that sentence again, make sure that you get all 4 points on the test. But it should be, there is a, and again, I'll just hedge my bets because this is right near that cutoff of 0.75. Moderate to strong, positive, linear relationship between magnitude of an earthquake and the number of deaths. So far, this seems pretty straightforward. That does make sense. Stronger earthquake, more people die. We're feeling pretty good about this interpretation. We got all our points. We got our strength, we got our direction, we got linear, and we got our context. But then it says, let's go ahead and create a scatter plot, which should have been the first thing we did. So I'm going to just do this by hand, as gross and terrible as that is. Looks like I need to go from a 6 up to an 8. So 7, 8. So, and then I've got to go from a 1 up to a 500. 100, 200, 300, 400, 500. Okay. So 6.6 is about 60. 8.3 is at 503. 6.2 is at 115. 6.6 is at 65, so another one here basically on top of that point. 6.9 is at 62. And 7.4 is at 1. So if we actually look at this data, it appears like we have some grouping, right? It appears like there's a group of data here, and then this one high outlier. Remember, we said correlation has issues with outlier. In fact, if we think about the trend, it looks like there's a very strong trend, and we just have this one outlier. So if I switch my computer back to not tablet mode, and I pull up this little calculator, and I go back into my lists, if I was to delete that one outlier, that 8.3, and the corresponding, go this way, and the corresponding 503 deaths, and I was to redo that linear regression, now look at what our R squared our R is, negative 9.9595. So without, R is equal to negative 0.9595. That completely changes the interpretation of our relationship. Now there is a very strong negative linear relationship between the magnitude and the number of people who die. So you're sitting there going, oh crap, we definitely need to do something more. This is when we would want to have a bigger data set. Obviously, 6 different earthquakes is not enough. And this is an extreme example, right? We have a very crazy outlier and a very small data set, but this is just trying to illustrate the idea of what a swing an outlier can make in terms of our interpretation and our correlation coefficient.